So today we will discuss about virtual machine virtual machine security vulnerabilities. So we know that the virtual machines are an important resource of a cloud computing paradigm. What is a virtual machine? Virtual machine, you know that it is an operating system. It is a guest operating system plus its applications and other virtual resources. Okay, so although we assume that in these virtual machines there is nothing which is going to be not secure, but even then there are many attacks possible on these virtual machines. And if we talk about the security of a virtual machines are supposed to be more secure than any kind of operating system. We know that a virtual machine is nothing but a like a program or a process which is running onto some physical hardware resources, right? And so that's why virtual machine is supposed to be more secure because it is actually acting as a logical process rather than a physical process, rather than a physical thing. It is a logical thing. And each virtual machine has some specific configuration and it is having some access control. Who can access, what he can access, in what way this access can be provided by the virtual machine. So all these things are actually controlled by these virtual machine layers. And we know that in case of cloud computing, a hypervisor is sitting above the hardware resources onto which different virtual machines are running. And this hypervisor is actually interacting or communicating with the virtual machines to provide requests for different kind of resources. So if the attacker is going to compromise this hypervisor, okay, it means that attacker will gain the access to all the virtual machines which are running over that hypervisor. Okay, and in that case, the attacker may also have a control over the host over which the hypervisor is running. In that case, the attacker will be gaining the access to the hardware resources onto which this hypervisor is going to provide the services. Right. So, though it is very difficult that attacker may compromise the hypervisor because hypervisor is going to be very, very secure, even more secure than compared to the virtual machine. But it is in case the attacker is going to compromise this hypervisor, is gaining the access to this hypervisor, all the virtual machines which are running on behalf of this hypervisor, they will be affected. They can be controlled by the attacker. So that will be the worst situation. Okay, and we know that in case of virtualization, this hypervisor is running over the guest. Okay, and we assume that there does not exist any communication between guest. Okay, so unauthorized communication between guests is actually violating the principle of isolation principle. And somehow, if the attacker is able to manage the communication between different guests onto which hypervisors are running, okay, it means that he may gain control over the shared memory. How these different guests would be communicating? They would be using some shared memory to communicate, and though one guest is not communicating with another guest, but if the attacker is compromising these guests and able to make a communication between different guests, so attacker may gain the access to this shared memory, and that's why the attacker may have a disaster onto this machine. Right. So like the physical machines, virtual machines are also vulnerable to the theft and denial of service attack. We know that Attacker may control the virtual machine, and attacker may attack onto the virtual machine, and attack could be some kind of a denial of service attack. In case of the denial of service attack, what happens? The attacker is sending a large number of packets on the network, and so that this virtual machine will not be able to provide its services to the consumers, cloud consumers, right? So virtual machines are equally vulnerable to the threat. Virtual machine can be compromised. Virtual machine can be controlled by attacker if the attacker is able to gain the access of this virtual machine, and that's why the virtual machines may be vulnerable. And in that case, the virtual machine will not be available for the particular cloud consumer, right? Also, you know that when these virtual machines are used by number of cloud consumers, okay, all the data of the cloud consumers uh, is going to be stored onto the virtual disk, right? Actually, this data is going to be stored onto some physical disk, but virtual machine sees a virtual disk to store all this data. So content of this virtual disk for each virtual machine is stored as a file. Okay. So all the contents of this virtual disk for each and every virtual machine is going to be stored as a file. Okay. And which is actually managed. Okay. Which is actually managed by the hypervisor. Okay, so physically this file can be stored onto some machine, but hypervisor will see this file for a particular virtual machine, right? And it may happen that the attacker may copy this virtual disk, which is the particular file for a virtual machine, and that's why by looking into the content of this virtual disk, the attacker may gain some unrestricted access to the contents which are available into this file of a specific virtual machine. Okay, so hypervisor is having a number of files for each and every virtual machine, okay, which are stored onto this virtual disk. Okay, and if the attacker is able to copy the content of this virtual disk, it means the attacker may gain the access to this the contents of this virtual machine, and that's why the attacker may have the access to this virtual machine and may attack or compromise this virtual machine. Okay, and we know that all these virtual machines which are communicating with the hypervisor, okay, from where they are getting the resources? They are actually getting the resources from some physical machines. Okay, below the hypervisor, we know that there are a lot of hardware resources, okay, which are actually available for all these virtual machines in a shared fashion. Okay, so virtual machines share resources from the physical machine. Okay, so that's why the virtual machine infrastructure becomes vulnerable also to the denial of service attack. It means that the attacker may gain the access of the hardware resources which are allocated to a virtual machine or which are being shared by different virtual machines into this cloud computing platform. Okay, so virtual machine resources becomes equally vulnerable to this denial of service attack. So in case of denial of service attack, what the attacker will do? Attacker will bombard a particular resource from a virtual machine, okay, so that that resource will not be available to provide its intended services to all these virtual machines. So in case of the denial of service attack, the attacker will try to block some of the resources from all these virtual machines so that these resources should not be available to the cloud consumers for providing a number of cloud services. So this is also a serious problem that the different kind of resources which are providing services to different virtual machines, they are actually going to starve. They are actually available, but they are actually controlled by the attacker, and that's why these resources are not available for the cloud computing services. Okay, so this problem has a solution. It can be fixed by limiting the resource consumption per each virtual machine. So what can happen? That the hypervisor can monitor what is the resource usage, okay, for each and every virtual machine. So if the hypervisor is seeing that a resource is being consumed a lot, then it can decide whether it is a attack or whether really the resource is being consumed by different virtual machines. Okay, so this is one solution. The hypervisor may keep watch on the resource utilization of all these virtual machines. Okay. So whatever the new products which are coming by different companies, they know this is actually a security concern, and they are actually leveraging hypervisors to continue to watch all these virtual machines resource utilization, so that the hypervisor may take a corresponding action depending upon the situation. So this is another problem in case of virtual machine. Okay, so one of the problem is mobility. You know that the virtual machines are not physical machines. Okay, virtual machines are actually the logical things. They are actually the processes which are running onto the hypervisor, and virtual machines are communicating with the hypervisor, and hypervisor is communicating with the hardware resources. Right. It means that when we say the virtual machine is not a physical thing, okay, so no physical theft of this virtual machine is possible. Okay, because virtual machines are just processes which are running onto some hypervisor. Okay, so no physical theft of this virtual machine is possible. Right. And we know that the content of the virtual disk for each virtual machine is going to be stored as a file, okay, by most of the hypervisors, okay, and which allows the virtual machines to be copied and run from other physical machines. So how to deploy the virtual machine at the instant of time? We know that on the virtual disk there is a file for each and every virtual machine. So we can host a virtual machine to another physical machine by copying the contents of this virtual machine file onto that physical machine. So that's why the hypervisor allows the virtual machines to be copied and run from other physical machines. So this is actually known as the migration of the virtual machine. So it is possible that virtual machines can be migrated from one physical machine to another physical machine, because they are actually going to be stored as a file, and this file can be transferred from one physical machine onto another physical machine. Okay, so this feature is actually quite convenient to migrate one virtual machine to another physical machine, but it is actually also creating a security threat. We know that the attacker can copy the virtual machine over the network, okay, and the attacker can store this virtual machine onto some portable storage media like a USB device or some other CD or DVD, okay, and attacker may gain access the data, okay, on their physical machine, okay, without physically stealing the hard drive. We know that attacker cannot gain access the physical hard drive onto which all this information is going to be stored, but attacker may copy the virtual machine, okay, from the network, and attacker may come to know a lot of information by running this virtual machine onto their own physical machines. So we know that it is a convenient feature of the virtual machine. Uh, I mean that a virtual machine migration is a convenient feature, but simultaneously it actually is having a security threat. So once the attacker have the direct access to the physical disk, to the virtual disk, okay, they have unlimited time to defeat all the security mechanisms such as password and other offline attacks. So once attacker gains the uh, file of a virtual machine, then attacker may try a number of attempts to steal the passwords, to steal other security important informations from that particular file. So that is actually going to be a serious threat for the virtual machine and the cloud consumers. Okay, and we know that since the attacker is going to copy the content of the virtual machine, okay, so the original virtual machine is not going to be affected. So the cloud consumer or the cloud service provider, they will never come to know that there has been an intrusion into the cloud computing system. Okay, because the original virtual machine which is running onto some physical machine, it will not indicate any kind of intrusion by any attacker. Okay, so that's why the hypervisor as well as the different virtual machines, they will not be able to detect whether there has been an intrusion into the system or not, because the attacker is only accessing a particular copy of a virtual machine rather than a original virtual machine. Okay, there is another danger of this virtual machine file, which is actually stored onto the virtual disk, and the danger is that the attacker may corrupt or modify this file of the virtual machine. So when the virtual machine is going to be offline, okay, attacker may modify this virtual machine file, or it may be corrupted by the attacker, okay, and that will be a problem to run this virtual machine again when it is online. Okay, it means that the integrity of an offline virtual machine may be compromised if the host is not securely protected. Okay, what does it mean by offline virtual machine? Means some cloud consumer is running a virtual machine, then after it the virtual machine goes offline, and in that case the correctness of the data of this virtual machine may be compromised by the attacker. Okay, so it is necessary that the host onto which this virtual machine is running should be provided some kind of information to verify whether the virtual machine has been corrupted or not. Okay, and we know that this is actually not a issue with the physical servers. Okay, because when we talk about the physical servers, okay, because all these machines must be running to be accessible by the network. So when some physical servers are there who are actually providing the services, okay, they are all the time running and they are accessible on the network. But in case of the virtual machine, when the virtual machine is going to be offline, then these virtual machines are not going to be accessible on the network. So what can be done? Uh, some mechanism should be provided with the guest operating system. Some mechanism should be provided with the hypervisor or the host so that they may know whether a particular virtual machine is going to be corrupted or not. So there exist modern encryption and integrity algorithms which can be applied by the host supervisor, okay, so that the integrity or the correctness of the data of a virtual machine can be ensured. Another vulnerability is hypervisor intrusion. So attacker may try to gain the access to the hypervisor, and we know that if the hypervisor is compromised, then all the virtual machines which are running on behalf of that hypervisor, they are going to be compromised. We know that hypervisor is responsible for providing all the resources between the host and the ghost, between the host machine and the guest operating systems. And usually the goal of the attacker is to attack on the hypervisor and to gain the access so that the attacker may execute any arbitrary malicious code onto the host to get the more control over all these virtual machines. Okay, so attacker may first try to attack on the hypervisor. If hypervisor is compromised, then attacker may try to execute some malicious code onto that hypervisor so that he may gain access more and more information onto the cloud platform. Okay, but if the attacker is not able to control or compromise or gain access of the hypervisor, then the attacker may try to gain access of a virtual machine which is running onto that hypervisor. Okay, so usually the hypervisor is very, very secure and it is not easy for the attacker to attack and gain access of this hypervisor. Okay, so we know that hypervisor is a program which is running on the host machine, and if it is going to be compromised or controlled or managed by the attacker, all the virtual machines it controls and the host will be available to the attacker for the entire information. So that will be the worst condition if the hypervisor is going to be compromised by the attacker. And we know that the hypervisor is converting the instructions which are coming from the guest operating system into the instructions which are for the host operating system. So host operating system is the operating system which is running on the physical machine, and guest operating systems are the other operating systems which are running in the form of virtual machines. So this hypervisor is converting the instruction which are coming from the guest operating system into the instructions which can be run onto the host operating system. So however, if the guest is going to be compromised, okay, so if the attacker is going to gain the access of the guest operating system, then the instructions which are supplied to the hypervisor, they will not be relevant. And that's why this hypervisor at that time may malfunction and it can provide some information to the attacker which should be a confidential information. So researchers have run two tools, CrashMe and IOFudge, which have generated random input-output port activity inside the virtual machines. And they ran these two softwares and generated input-output activities in the virtual machine till the time the hypervisor or virtual machine crashed. And that's why they come to know that they were able to compromise the hypervisor and they were able to access the host using any major hypervisor available to the public. So what is the idea? The attacker may use the same technique. The attacker may run different kind of tools, and attacker may generate some false activity onto these virtual machines till the time the virtual machine or the hypervisor is going to be crash. And after that, the attacker may gain the access of this hypervisor and may access the resources which are available onto the host physical machine. So hypervisors usually are very, very secure that compared to the operating systems. And hypervisor is, it is a very small program, okay, and which can help to limit the low-level vulnerabilities that may be present in your programs. So what happens that it is also necessary to secure the guest operating system. So if the guest operating system is not going to be secured, then the attacker may gain the access of the guest operating system in a physical machine and that can have a severe damage to the hypervisor layer. And that's why the hypervisor may also be compromised by the attacker at some period of time. Another is the hypervisor modification. So attacker may try to alter the parameters of a hypervisor. Okay, we know that it does not matter how secure the original hypervisor is. It can be externally modified to use the attacker software. So attacker may alter some parameters into the hypervisor, and that's why the attacker may run its malicious software onto that hypervisor to gain further access. Okay, what attack of this form is actually known as the virtual machine based rootkits. Okay, in case of this virtual machine based rootkits, the hypervisor system call to the host, they are changed so that they may run the malicious code provided by the attacker. So what the attacker will do? Attacker will try to modify some of the parameters into the hypervisor, and then after attacker will try to run its malicious code using this hypervisor onto the host machine. And that's why the attacker will try to have more and more access of the information into your system. Right. And there are several methods for preventing such kind of hypervisor modification. What are the different methods? One method is that the host can use a trusted platform module to create a trusted relationship with the hypervisor. Right. So this host machine can have this software module, okay, which can ensure the trusted relationship with the hypervisor and which can verify up to some extent whether the hypervisor has been modified or not. Alternatively, the guest can verify the integrity of the hypervisor when it is booting. You know that guest operating system is booting with the help of the hypervisor. So before guest operating system is running its application onto the hypervisor, it can verify the correctness of the hypervisor when it is going to boot. Okay, so that's why the guest operating system may come to know whether the hypervisor has been modified by the attacker or not. The third solution is to use a embedded hypervisor. So what is an embedded hypervisor? Embedded hypervisor is a hypervisor which is running without a host operating system. Right. So since it is not running with a host operating system, it is very difficult to modify. So generally the attacker will try to modify the host operating system. Okay, so since a embedded hypervisor is running without a host operating system, and it is very difficult to modify this embedded hypervisor. So these are the three solutions which can be used to overcome this vulnerability, which is actually known as the hypervisor modification. Another vulnerability is communication. Okay, so this virtual machine communication is refers to as guest-to-guest attacks, in which the attacker will use one virtual machine to gain access or control other virtual machine on the same hypervisor. Okay, so attacker may run its own virtual machine, and that virtual machine may communicate with another virtual machine which is running onto a particular hypervisor. So using this communication with the other virtual machine, the attacker may try to gain access over all other virtual machines which are running onto that hypervisor. So this kind of attack can happen without gaining control or compromising this hypervisor layer. Okay, so attacker can run a malicious virtual machine. Okay, and this virtual machine can access other virtual machines through shared memory, through network connections, and other shared resources. Okay, so for example, if a malicious virtual machine determines where another virtual machine's allocated memory lies. Then, okay, you know that the communication in distributed system happens through the shared memory. So if the attacker is running a virtual machine and attacker comes to know where the allocated virtual machine memory lies, then its malicious virtual machine can read or write to that location, and that's why it can interfere with the operation of the another virtual machine, which is running on to another kind of hypervisor. Right. So in the next figure, you will see an attack from virtual machine 1 onto two different virtual machines, virtual machine 2 and virtual machine 3. The attacker may or may not be authorized to gain access virtual machine 1, but in this example has access to unauthorized virtual machines. So you see in this diagram that the attacker is using this virtual machine 1 to gain access on virtual machine 2 and virtual machine 3, and all these virtual machines are actually running onto some hypervisor. So how it is possible? All these virtual machines which are running onto this hypervisor, they are actually communicating through shared memory, and if the attacker comes to know where this shared memory lies into the system, then this attacker can read the contents from that shared memory, and that's why the attacker may gain access over any of the virtual machine which is running onto this hypervisor. So in this case, you will see that uh, using the communication among the different virtual machines, the attacker is trying to gain access over the virtual machine 2 and virtual machine 3 using the virtual machine 1. So that is also a security vulnerability in case of a virtual machine. We know that when there are various virtual machines which are running onto a hypervisor, it is desirable that these two virtual machines are able to communicate using this shared memory. And you know that and this communication between the virtual machines using the shared memory has a number of applications. For example, dedicated monitoring of a virtual machine. Okay, implement network technology that requires multiple virtual machines. Okay, and if you look at the IBM's S Hive is having this secure architecture for addressing this inter virtual machine communication issue. Okay, so this S Hive allows system administrators to define policies for communication between each virtual machine and ensure that only authorized virtual machines have access to communicate with other virtual machines. So IBM's system is having a secure architecture for communication between the virtual machines, and that secure architecture allows uh, and ensure how these different virtual machines are communicating with each other. Okay, and it ensures that only the authorized virtual machines are communicating with other virtual machines onto that hypervisor. So this could be one of the solution of this problem. Another kind of vulnerability in case of virtual machine is denial of service. Okay, so what is denial of service? The attacker is bombarding the system with a number of false packets so that a particular resource is not able to be utilized to provide any kind of service. So this denial of service attacks are a threat to all the servers. However, we see that improperly configured hypervisor, it may happen that if the hypervisor is not properly configured, in that case, it may happen that a particular virtual machine is consuming all the resources, and all other virtual machines, they are not getting the required resources to run their services, right? So this situation might happen and it can be considered as a problem. Okay, so this hypervisor should be able to determine whether it is actually allocating all the resources to few of the virtual machines or whether there is a attack onto the hypervisor so that the resources are not available to different virtual machines. Okay, so this denial of service attack, it will make the host unavailable to function. Okay, because the necessary hardware resources are not available, because these hardware resources are going to be compromised by the attacker and they are being utilized heavily by the attacker in its own way, and that's why these hardware resources will not be able to provide the intended services. So what is the solution? The solution is a simple solution. Hypervisor may try to monitor all these resources. So hypervisor will try to prevent any virtual machine from 100% utilization of any of the resources. So hypervisor will monitor what is the resource usage of each and every virtual machine with respect to different resources like CPU, like RAM, like network bandwidth, and other things. So hypervisor can also be configured in such a way so that it can detect which virtual machine is going to use a resource very heavily. Okay, so it can evaluate whether it has been due to some attack or whether the virtual machine is consuming all the necessary resources, and that's why the different virtual machines, they are not able to get the required resources. And if it is finding that the particular virtual machine is utilizing the resource up to its 100%, then hypervisor may automatically restart that virtual machine. We know that virtual machines can be quickly restarted than the physical machines because they do not require to boot like a operating system, and they do not need to initialize and verify other hardware resources. So restarting a virtual machine will not have a very significant effect on the performance of the cloud computing services, but it will be having a very smaller effect than compared to a starting of a physical machine. So this is one solution that can be there, okay, to deal with this kind of problem.